Thanks for buying Integrating SignalR with ASP.NET Core and Angular. My name is Sean Wildermuth of Wilderminds. In this micro course, we're going to be talking about using SignalR specifically in Angular. I'm going to be using the latest version of Angular that's available at the time of this recording, which is April of 2019. We're going to do this by creating a service in Angular using SignalR. I'll show you how to use SignalR with reqs. And then I'll show you how to call back into the server to broadcast your own messages. This micro course isn't meant to give you an introduction to SignalR. We make the assumption you're already familiar with the basics of how SignalR works on the server. If you've taken our micro course on SignalR, you'll be sufficiently ready to take this micro course specifically on how we're integrating with Angular. This micro course is focusing specifically on how to integrate SignalR with Angular. And the code we're going to be showing is almost exclusively client-side code. Enough talk, let's get to the code. Let's begin by getting the starting project. Over in the browser of your choice, if you go to github.com/wildermindscourses/SignalR with Angular, you'll run into this repository which has all the source code for the starting project. This way you don't have to build up an entire ASP.NET Core project and have SignalR already implemented. If you're not familiar with Git and making a clone of this project, simply go to this green button and download the entire source code as a zip, and you'll want to go ahead and open up the solution file inside that zip file. I've conveniently already have that project opened up in Visual Studio. I'm using Visual Studio 2019, but this works just the same as with Visual Studio 2017. And let's just give you a quick run through. I have an Angular app already built up. And so if we run this so that you can see actually what the application is doing, it's similar to the one that was in the first course, there is a Help Center page, and this is where we can go ahead and put in our request. The printer isn't working. And when we save that, it gets saved to a database that we can see on the call center link. The call center link is an Angular app that has two different pages. It has this call log, which is all the requests for help in the database. And when we open one, we can see all the details about each call. We can either go back or mark it as answered. And this works as is. If we go to marked as answered and go back, we'll see this is missing. Where we want to integrate SignalR is the ability to be able to let other people that are running the same application know about those changes without constantly refreshing the page. So like as a call is answered on a different computer or even in a different space, that they get a message saying, hey, this call's been answered, take it off the list for me. And so that's what we're going to accomplish by integrating into our Angular app. Back in the source code, a couple of things you're going to be aware of, especially if you didn't view the first micro course, is that in startup, we're enabling SignalR here, but more importantly, we're listening to a hub called the call hub that has the functionality we've been talking about at this URL, API/call hub. And this hub specifically just allows us to notify that a call has been answered or that if someone has created a new call. Those are both operations we're going to go ahead and implement in our Angular app in this course. So now you've seen a tiny bit of the code. Let's go ahead and add SignalR to our Angular app. So let's introduce SignalR into our Angular app. In the case of our project, we've got a client directory that contains our Angular app, and inside of it is a source directory with all of the code we're going to be dealing with. On top of that, directly in that client directory, there's going to be a package.json, and this is where all of the requirements for our Angular app are going to exist, both development time as well as runtime. And we're going to need a new package called ASP.NET, at ASP.NET specifically, SignalR. And I'm going to use the 1.1.4 version, which is compatible with ASP.NET before 3.0. On 3.0, there'll be versions that are going to support some new features that they're going to be talking about. But for now, I'll just pick the 1.1.4 for now. Behind the scenes, Visual Studio is going to go ahead and get that requirement. If you're working on Visual Studio Code or some other IDE, you'll actually probably need to run npm install to go ahead and add this new requirement. But if you are, you're probably already familiar with this problem. And now that we have it, we should be able to just use it directly inside of our source files. And so we're going to first start and implement using SignalR to be notified about new calls that have been added directly in our views. So if we look at the app directory, which contains all of the actual application code, inside the views directory, there's going to be a component for call That's to show single call, and then the call list. And we're going to deal with the call list one as the ability to add a new call as it's added at another computer. The first thing we're going to do is go ahead and create a member, a private member specifically, called the client. And we're just going to type this to a hub connection object. And we're going to get this by just calling import hub connection from ASP.NET SignalR. This is going to be a type that's included in the SignalR. And in the constructor, we're just going to set this by saying client equals new hub connection builder. This is a special type of class that will build up a connection for you. And it's a fluent syntax, so we're just going to say with URL. And that URL is going to be the same one we saw earlier, API call-hub. And then we're going to call build. Of course, we need to add to this. This will go ahead and build up the connection. It won't start the connection or listen to any specific things. It's just building up that client object that we're going to need. We also want to say this dot client, and this is where we can start to listen for messages. And here we're going to give it the name of a message and then a callback for that message. So if we go over to our hub, we'll see that the message we're actually looking for is the new call message. So let's go ahead and put in the name there, new call. And we can see that we're actually passing in a call that represents the new object. We're passing it in to call ourselves back. And so back here in the main code, we can just say, oh, I guess we're going to get a call object through this. And if we look down here, we can see we're actually using something called the call service that holds our network operations and actually our calls themselves. We can see that when they're loaded, we're setting the calls with the service.calls. So what we're going to actually do is call the call service, add call, and pass in that call. Now this add call just adds it locally. It doesn't save it to the database or save it to the service. It just adds it to our client-side list of calls. And so we're saying we want to connect to the hub. When the hub notifies everybody that there's a new call, I want to be on that list of people notified. And then finally here and after content init, which is when startup happens, we can actually see that we're using that load like we talked about, and then we're subscribing to the callback. Here we can say start listening. Once the listening has started, we can go ahead and just see that as new calls are created in one part of the app, it'll show up in a wholly different browser. This isn't because we have a SPA running our one whole project. It's that we're using SignalR to send a message from the server down to this call list component. If we run it, in here I have the same app in both browsers. Now we have the app running in two different instances of our browser. So it could be separate browsers, they could be separate machines, and this should still work. So we just have Jake go ahead and send us a problem, and of course the printer isn't working again. If we go ahead and save that, we can see it show up here completely disconnected from the other page. This isn't even an Angular page. This is just a simple post form to the server. And so by utilizing this, we can really get that server-side communication pushing down to this. Though I'm not a big fan of integrating this directly in the view, let's see another way. Let's create a service for SignalR. Back in Visual Studio, going to create a new service inside of our services directory, and I'm just going to call it the callhub.ts. And inside this call hub, we're going to export an object called callhub. No base class, we're just using a class to represent our wrapper around the hub so we can use it from different places. Need a constructor because we're going to need to support the ability to actually create our hub. And if we go ahead and look at that view we had earlier, the call list component, we're going to want to do a lot of what it's already doing. So let's copy our client up here into the class. Let's initialize it in our constructor like we did. And if you're lucky, it'll go ahead and help you with some of the imports. And we'll just create a method for starting our client so that whomever's using this service can actually just use that. Now, we haven't done a lot with this yet, but let's talk about how we're going to actually support injecting this, because we want to replace in our call list or even in other services the use of using the connection itself with this wrapper that might make it a little easier to reuse across components. And we're going to do that by using a decorator called injectable. And this injectable decorator is going to specifically tell it that we want to be able to inject this into anywhere in our application. If you're familiar with Angular, you've probably done this before. And the provided in just says at what level, without us having to register it as a separate injectable object either at a component level or even at the module level. We're just saying allow this to be injected anywhere, right? And so we've got the very minimal amount of functionality here. We don't have registering for certain calls. And in fact, instead of hiding the client itself, we'll go ahead and let's rename that into just client, and let's make this public. That way anyone using the call hub class can have exposure into the client itself to do what it wants to do. So let's go ahead and look at the call list component. Let's use our new injectable call hub instead. So let's say this is going to be private call hub as call hub, and we'll probably need that to be added to our project, which we can go ahead and get. And instead of this code, going ahead and setting it up so we can have these things about the connection be sort of reused across our application, here we'll just change this to call hub.client to set up that registration, right? We're still exposing the call to be able to register for a new call if we want to, but this way we have a wrapper around it. And you could go one further and actually have callback mechanisms where you're sending messages or other callbacks that are being called for you to even hide this level of functionality. That's really up to you how much you actually want to embed it. The last piece here, of course, because client is not going to exist soon, is to call the call hub and call its start method. And of course, we can get rid of our private for the hub connection here because we're not actually going to create the hub here. We're just going to use our wrapper service instead. If we come over here back to the watched ng build, you'll see that it's gone ahead and rebuilt it for us. So we should just be able to go back to these pages. Let's go ahead and refresh and see if it still works now that we've done this refactoring into a service. So if we come back here and create Phil Smith, Phil also has an AOL address, but none of them can use a printer, so maybe those are related. And when we go ahead and save it here, we can see that it's gone ahead and saved and added our new Phil Smith. So we have fundamentally our code working, but I'm still not a big fan of exposing all those details. Let's see a different way to do this next. So now let's see how SignalR and RxJS can work wonders together. So back in our call hub, we made this connection public, but I actually would prefer it to be private so that we're not dealing with the client directly. We want to be able to wrap that and deal with it in a much simpler way. So the first thing we're going to want is a private member that I'll just call new call message. This will be a type from RxJS called subject. And because we don't have call defined as a type, I'm just going to use any right here. You could certainly specify the subject as something that could be notified about changes to as being a concrete type. But we haven't gone through the trouble of actually creating an interface for our call. So I'm going to try to do this pretty simply. And I'm just going to import subject from the RxJS object like that. And how are we going to actually deal with this new message? We're going to deal with this by actually exposing a new method, new call message. And all that new call message is going to do is return our new call message as observable. This as observable is important because it's exposing an observable object that we can then notify someone about this arriving. We're essentially using an observable as a message pump. But it means that here inside of our constructor, we're going to want to go ahead and use the client to call new call again. So we're now going to have the messages we're listening for buried or hidden inside of this call hub. And what are we going to do when we get a new call? We're just going to say this dot new call message next and pass in that call. And what's happening here? Our subject here is saying, hey, if anyone's listening or has subscribed to me, I'm going to send you the next call that is being added from somewhere in SignalR. And the reason this works is then back here in the call list, instead of us having access to that client, it's giving us an error because we've hidden it. We're not going to know about how RxJS necessarily works. We just know that the call hub has a new call message that we can then subscribe to by giving it a callback that we're going to be called. And what are we going to do in this callback? We're still going to do the same thing, but this way the semantics of SignalR don't need to be exposed to us. All of what we're doing here is very standard RxJS that we are probably already familiar with in Angular. So once you build this call hub, this is hiding a lot of the messy details of how SignalR is actually working and just using messaging within Angular to actually do its job. And this is an important idea because as things change with SignalR, as you may opt into new messaging messages, or you may want to talk about throttling or who knows what. You want all that hidden inside of this call hub, so its single responsibility is just SignalR. And then whomever is using it, they don't have to understand or know about the details of SignalR. It just knows that we have a hub where new call messages are going to come in, and then we're going to deal with them appropriately. Hope that makes sense. Let's see this actually working. Make sure and refresh both pages, so we're going to get the new version. And when I refresh it, it's going to actually not work. And that's because I've made a boo-boo in here. We're getting a weird Angular error. And I say weird in that Angular isn't really telling us what we're doing wrong, but it's probably somewhere inside of our call hub. So we look back here in the call hub, I'll notice that we're trying to use this new call message here when I call next, and it's freaking out because we defined it, but we didn't actually create it. So we actually have to change it to new subject any almost, because we're actually going to create a new subject object for ourselves. And because it's building in the back, it should continue to work. Let's refresh our page. We can see it's back working, so let's get rid of that. Let's make sure that the new objects are actually doing what they're supposed to do. And our printer is on fire now. Probably need an urgency in here. We can see Bob's still working, even though we've now hidden all those details inside of our call hub class. And we could have a handful of these classes for the different kinds of hubs we're dealing with. We don't have to have it as a one-to-one where we're going to put all our messages on one giant hub. It really depends on how you want to scale it out and such. But I still don't like it because we have this data service. We have the service that's dealing with our data itself, and we already have things wired up. Why do we even need it in the view? Why don't we just use our call hub directly inside of the API service itself? Let's do that next. Now let's integrate it directly into our data service. Back in Visual Studio, let's go back to that call list, and let's go ahead and just get rid of our call hub in here. Because we already have our call service here and us dealing with the call hub, the calls actually changing. We're already using this call service to actually do that for us. So what we're going to want to do in here is actually integrate it directly in the constructor. So we're going to create another private call hub, and this is going to be of call hub type, just like we did before. Go ahead and import that, and then we'll just use the call hub just like we did before. Call new message, subscribe, call, and this time we're just going to call this dot add call, right? We're going to do the same thing we did before. This way, any view that's actually using this will go ahead and find out about new calls. It doesn't have to be necessarily each and individual view is going to care about registering for that add call itself, but you're going to say the actual owner of the data, this call service that has the API calls and has the ways to get individual calls and things like that, will already handle this for us. Now that we've added the new call message, let's head down here and make sure we start the hub. So if we look at the call for load, we'll see that there's sort of two chains. There's one load that happens if is loaded has already happened, but down here is where we're actually getting the API call. And so what we want to do is once the API call happens, we want to go ahead and right before we return true, is go ahead and say this.callHub.start. This will make sure that we start the hub once and only once, and that'll happen as soon as we get all the data from the server. Really what we're doing with SignalR is keeping the internal state of our data the same as it is on the server and the same as it should be in every browser using our application. Let's go ahead and run this. And let's make sure that we have a fresh page on both of them. Let's go ahead and have Jake add a new service. Jake's another AOL guy, and he says the fire is getting worse. Oops. Let's go ahead and save that. And because we've embedded it directly in the call service, or the service that is responsible for the data, we should see it just show up here because our view here is going to react to the change in data. This way our views can be somewhat agnostic to where the data is coming from, whether that's the API or whether that's the call hub, and it allows us to really centralize that across our entire application. We have two views here, so who cares, right? May not be necessary to do that, but as you get a larger and larger application where you may be having subviews or you may be having multiple of these views shown on a single page, you don't want to necessarily integrate this hub everywhere. You just want to be able to integrate it in some deep fashion that will be exposed everywhere. So now let's talk about calling the server. Let's do that next. Let's call the server from the client. So back in Visual Studio, inside of our call service, we actually do something in here on the second page where we say, let's go ahead and mark our code as answered. What happens here is we mark a call as answered and we want to be able to notify it so it disappears from all the other pages. New call is going to add it to all the other pages. Mark the call should remove it from all the other pages. So what we want to do here is after the actual patch call is finished to mark the call as answered, we're going to just say this.callHub, and then we want to actually execute the resolved call. And so let's just call it resolved call and pass in our call. So back in the call hub, we're going to add a new method here called public resolve call, where we're going to accept a call object. And what we're going to do here is simply say this dot client invoke, and we're going to invoke the name of a call. If we go back to our hub, we can see that the second kind of call here is call answered. That's the message we want to send up. And when we call it from the client code, this actually gets executed. And what this does is it says, go call everyone else, not me again, but everyone else that has registered for called answered that a call has been handled. So we'll invoke call answered here, and then we'll pass as that second parameter the actual call that's being answered. And this is interesting because what we really want this to do is send that call information to all the other listeners for it. Now this would work if the other listeners were actually listening for that event as well. So we're going to want to come up here and do the same thing we did with onClient for call answered. And because both of these calls take a client, we can actually do exactly what we want to do, and that is expose a subject for it. Again, we're not going to know necessarily in our call hub what you're going to do with that information that a call has been resolved, but we'll call this answered call message. And we're going to set it up just like we did before, but here we'll say answered call message dot next call. Again, this is the RxJS way of saying, hey, here's the next value for it. And then down here, we're going to need to expose answered call message, just like we did before, and just return this dot answered call message as observable so that people who care can really handle this. Now this gets a little confusing because we already have something on the surface that is removing a call when someone clicks a button for resolving a call. This is for some other page that actually resolves the call that's going to call back into us with that information. And of course it's complaining here because we have the same idea for both. I'll just call this answered call message. This is one of the reasons why we used a cap here before. I'll go ahead and use a cap, though because this is JavaScript, it makes me a little weaselly about that. But I'll go ahead and call it answered call message, and then back in our call service, let's make sure we had the right name there for resolve call that we called it. Always pay attention to those error messages. But up here, when we create the message, just like we subscribed to new call message, we're going to do the same thing for call hub dot answered call message and just subscribe to any changes we get. But this time we're going to actually say remove call. In our world, this remove call, let me go down here and show you what it is actually a very simple method that just removes it from the existing array. It doesn't actually call the API or anything. Marked as answered does that. That's why remove call is private. It's only being used to do cleanup within the call service. So when someone clicks that marked as resolved button, we're going to call this as part of actually changing the data. We're going to call the hub and say, go ahead and notify every other browser that cares that this call has been resolved. But it's not going to call back into us. But if someone else calls this method in their browser, we're going to come up here and get this answered call message called back to us so that we can remove it from our own list. So what does this mean in practice? So we go back to the browsers. I'm going to actually go and have the call center open on both pages, right? And if I open up, let's say Jake, we have this mark answered. Let's make sure I've got fresh copies of both of these. If I come up here and say marked answered, locally I'm going to remove this as soon as I press mark answered, but because they're in different browsers, this should also want to remove it because I'm using SignalR to send the message. And this way we can maintain both lists, even though they're on different computers, different machines, different offices even are going to be maintaining the same list. So let's get rid of this Bob Smith in the middle of the list. So you just don't think we're getting rid of the middle one, right? And this is one of the powers of SignalR, is to be able to allow these very simple operations that should work great, but that we've had to make some really weird web-centric things to sort of fix this in the past. Let's wrap up this micro course. So I've shown you a few ways to integrate SignalR with Angular. Some ways that I think are useful. You're obviously going to find your own ways that match your own applications in their own ways, but hopefully I've given you a sense of some key ways to go ahead and integrate it. I've shown you the SignalR integrates with just a simple library and a couple of pieces of code to create a connection, listen for events, call back into those events, and then ultimately start and stop listening to the server. How you do the integration really depends on what requirements you have. You may find just at the view, because you have a one-off need for SignalR, it's fine for doing it in a project. But as you start to look at a more wide-ranging messaging story with SignalR, you might decide to further integrate it deeper into your application. SignalR supports those sort of notifications from server to client that we've never had a really good answer for. We know how to send information from the client to the server, but doing notifications from the server to the client has always been difficult, and using SignalR with Angular really gives us a great platform for doing that. Thanks for buying this micro course on SignalR with Angular. My name is Sean Wildermuth of Wilder Minds. Remember to leave a comment if you have any questions.